Hello students, welcome to the another session. Hope everybody is doing great. Let's begin the new chapter called System of Particles and Rotatory Motion. System of Particles and Rotatory Motion. And this is the chapter is also called in some of the books. It will be written as a rigid a body dynamics, my dear students. A rigid body dynamics. So what is rigid body we should understand first. What is rigid body we must understand first. Let's see. Imagine I have a body is like this. This is a metal block. So this is the a metal block which I am referring as a rigid body. Right? Rigid body must have a definite shape which must be an unchanging on application of a deforming force. See here. This is the rigid body, a metal block I have taken, which must have a definite shape that is unchanging on application of the deforming force. This is what? On application of the deforming force, comparatively, that is important, comparatively. Yakandre, there is no perfect rigid body in the nature. There is no perfect rigid body in the nature. So let's take an example of this one. So I have a sponge here on which I am applying a force like this. Look at here. On which I am applying the force. The shape of the body is changing here. So the definite shape which is changing here in this case, look at here. So this is, I can say it's not a rigid body. And at the same time, I'm taking another body here. Look at here. This is the body made up of plastic here. The same amount of force I am applying on this body, my dear students. So, is there any change in the shape of the body? No. So, this is the body is definite in shape, whatever it may be, regular or irregular. So, this is a definite in shape and which is unchanging on application of a deforming force. Yes, the same force I applied on a sponge, there is a change in the shape. The same force I applied on this rigid body, there is no change in the shape. So, we can say comparatively, this is what? The rigid body, right? And this rigid body dynamics we are discussing. So when it comes to the point called dynamics, here, this rigid body can move or can undergoes in translatory motion, and a rotatory motion. This rigid body can undergo, instead of move, we can write exactly speaking, can undergo translatory motion and rotatory motion. So what exactly meant by the translatory motion and rotatory motion, I'll tell you here. Listen carefully. Simple. Number one, translatory motion, my dear students, translatory motion. So what is there in it? Look at here. This is the ground. Simple. This is the ground. There is a body I have taken here. Is the rigid body. So you look at the name of the chapter once again. System of particles. So generally so far, just before this chapter even, For example, let's take a work power energy chapter. So look at here, this is the ground. From the ground there is a mass which is taken to the some height. So the at this height, so the energy stored in the body is potential energy, which is equal to mgh. So that's what we discussed, and that m, that's a point mass. That's not the system of particles. That's not a rigid body. That's a point mass which is very, 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 very small in size and mass. So this is what the small mass called point mass. Now we in this chapter we will discuss about the collection of these point masses in a system, my dear students. So this is the rigid body where a number of point masses will be there. Number of point masses will be there, right? So if you consider this is a rigid body, look at here, there is a point mass here and there is a point mass here. So there is a point mass here and there is a point mass here. Like this n number of point masses are there in this rigid body, and that is called system of particles. Each particle is a point mass. So many point masses are collected. That's called system of particles. Okay, now look at here. This is called the translatory motion we are talking about. Don't think that the translatory motion is always a straight line motion like a rectilinear motion. No. Understand? Don't think like that. Rectilinear motion under straight line motion. Translatory motion is different than the rectilinear motion or the straight line motion. Right? So sometimes, so the coincidence may happen. So this is the body is moving in a straight line now. So we can say that is a translatory motion. But what exactly meant by the translatory motion, I just wanted to mention here. Have a look at it. So there are n number of masses are involved, n number of point masses are involved in the system. Now there are 4 points I have considered, right? So this point, this body is moving with some velocity v and there. This point in the system moves with the same velocity v. This point in the system moves with the same velocity v. And this point in the system moves with the same velocity, and this point of the system also moves with the same velocity. So that's the interesting part of the translatory motion. Each and every particle of the system moves with the same velocity, and that's called, this is the first mass m1, and this is the mass m2, and this is m3, and this is m4. So that's called the translatory motion. And let's see, the next one is about a rotatory motion, my dear students. So this is the most important part of this chapter. Rotatory motion. A rotatory motion. Circular motion is different and rotatory motion is different, but there is a connection between them, right? So what is rotatory motion? Let's have a look at it. For example, this is what a rigid body I have taken, my dear students. This is what the rigid body I have taken. See, this rigid body can move in a translatory motion. Yes or no? This rigid body can move in a translatory motion. So if the rigid body is moving like this, each and every particle in the rigid body moving with the same velocity, right? That's a translatory motion. Now this rigid body can rotate also. Let's have a look at it. Imagine this is what the axis of rotation. About this axis of rotation, this rigid body can also rotate. Okay. About this axis of rotation, the rigid body can also rotate. The same thing I just wanted to show here. So for this, I'm just taking an example of the fan, my dear students, right? So this is what the midpoint here. From here, so these are the wings of the fan. Look at here. 1. These are the wings of the fan. Look at here. So this is the body will have system of particles. This body will have system of particles. This wing also will have system of particles. N number of particles will be there here, here, here. This is the complete system which is rotating. About any particle on the system you take it. Any particle on the system you take it. It is rotating about a fixed axis. So this is what the fixed axis. About this fixed axis, the system is rotating about a fixed axis. Each and every particle making a circular path about a fixed axis. That's called the rotatory motion. For example, let's see, there is a mass m1 here, my dear students. The mass m1. Concentrate only on that particular mass m1. And this m1, how it is rotating, only that particle about the circular path, about this axis of rotation, how it moves in this way, right? With the radius of the circle r1, observe everybody. Now there is another particle I can take here. So this is what the particle of mass m2, and how this particle moves about this axis of rotation. Same way, when the fan is on, so this particle also will move in this circular path, my dear students, whose radius is r2. Observe Madri carefully. Two arbitrary means anywhere. Two arbitrary points are considered on the system, and m1 is the particle moving in the circular path about this axis of rotation, that is the rotatory motion. Rotatory motion takes place of a particle, and it must take place in a circular path about a fixed axis of rotation. Fan axis of rotation is fixed, right? Earth axis of rotation is fixed. Earth will be rotating about its own axis. That's called the rotatory motion, my dear students, right? And here also the same. The second mass is also taking a circular path about this fixed axis of rotation. In rotatory motion, we should understand one important point, my dear students. We know the relation between linear velocity and angular velocity. So V is equal to R omega. What is that? V is equal to R omega. So linear velocity, how we'll find out? In a circular path, if a particle is moving, linear velocity, how we'll find? So we'll draw the tangent at different points. Look at here. At this point, if you want the linear velocity, look at here. Have a look at here. At this point, for example, our particle has started from here, right? Our particle is started from here. So this is the point. Okay, let me take the point has started from here, my dear students, so that no confusions will be there. This is the first mass and second mass, started from point A and point B. Okay, so at point A, imagine, so this is the fan is rotating in the clockwise direction, in the direction of motion. So the first linear velocity is V1. And this linear velocity is V2. Linear velocity is V1 and V2. Why? A linear velocity is varied because radius is different in both the cases. First particle radius is R1. In which circle it is moving? The first particle it is moving with the radius R1. Second particle, in which circle it is moving, that's radius is R2, my dear students. So V is varied because R is varying. Right? So each and particle linear velocity is different. When the circular path is changing, each and every particle in this system of particles, each and every particle linear velocity different because the radius is changed. So now the interesting part is omega, my dear students, and you know this omega is equal to theta by t. Did you remember this? Angular velocity is equal to angular displacement by time. Okay, what is angular velocity here? Look at this, angular displacement. For example, so the particle A is here. Listen, particle A is here. Particle B is here. After some time, look at this. So both the particles have reached here. After some time, both the particles have reached here. So this is what the particle B dash position, and this is the particle A dash position. See here. How it is changing from A to A dash and B to B dash. Have a look at it. So A to A dash, B to B dash, A to B to B dash, and A to, see this is A to A dash. So what happened? See here, this is what angular displacement. Angular displacement taken B to B dash and angular displacement taken A to A dash is the same. Yes or no? Yes or no? So for your better understanding, I am drawing here also, my dear students. Look at here. For your better understanding, I am drawing here also. So this is what a circular path. So this is what the origin, right? Center. So there is a particle A here, there is a particle B here. After some time, see, after some time the B has reached to B dash, after some time A has reached to A dash. So this is how they have reached. Look at here. This is how they have reached. So for both A to A dash journey and B to B dash journey, this is what the angular displacement है. Tell me. Answer me. Answer me in WhatsApp. Yes or no? Yes or no? There is a particle moving from A to A dash. There is a particle is moving from B to B dash. So both angular displacements are same. Theta only, which is 90 degrees, which is pi by 2. So this theta is called what? Angular displacement. So this is the heart of the chapter called system of particles, my dear students. Heart of the chapter. A body is moving in a circular path about a fixed axis under a rotatory motion. Angular velocity will be same. Linear velocity will be different. Why the linear velocity will be different? Because the radius of each circle is different. Radius of each circle is different. That's an important point. When the particle is moving in a rotatory motion, making a rotatory motion, at any point you take it, linear velocity will be different and angular velocity will be same. Because why the angular velocity is same? This is the reason. Look at here. Angular displacement is same. Angular displacement is there, divided by time is the omega only. Understand? Clear? So if you take, this is the wing of the fan, complete wing of the fan, in a same time it comes here while rotation. Right? In a time t, the complete wing of the fan will come here. So this is what A double dash now. This is what the B double dash now. Both the wing will come at this point in the same time from here to here. First A double dash will come, then B double dash will come anta ಏನilla. Right? So A double dash andre ಏನು? So this is the first point, the second point, and third point of the A, like that. Understand? This is about the rotatory motion, my dear students. I hope it has given you the clarity what exactly meant by the rigid body, what is a definitely shaped body, and unchanging application on unchanging the definite shape on application of the deforming force. So then we have discussed about the rigid body must undergo the translatory and rotatory motion. What is meant by the translatory motion? What is meant by the rotatory motion? We have discussed. Rotatory motion we have focused so much here because it's the heart of the chapter I told you. And V is equal to R omega, my dear students. In rotational motion, V is different. Omega is same at any particle, at any position, right? So that's it. Now, the topic of our discussion is the center of mass, my dear students. So, just pause the video and write down. Pause the video and write down. Right. So, now the topic is center of mass. Center of mass, my dear students, denoted Cm, right? Center of mass. So simple. There is no difficulty involved in it. Center of mass means it's a point. It is just a point. It is the point at which the total mass of the system supposed to be concentrated. Simple. Total mass of the system is supposed to be concentrated, right? Imagine. This is the system. System of particles. Look at here. This is the system where system of particles are present. The total mass of the body will be supposed to be concentrated at one point, right? So that is called the center of mass at any point, right? Any point, depends on the mass distribution. So let's have a look at the same object here. This is what the rigid body. which will have system of particles, number of particles. The total mass will be supposed to be concentrated at one point, right? Mass of this body is, for example, 500 grams if I take it. That 500 grams will be supposed to be concentrated at one point, and that is the point is called center of mass point. Understand? So, center of mass point, if we know what is the advantage for us, that's important, right? What is the advantage for us? So, look at here. The center of mass concept will describes the translatory motion of the body. Translatory motion of the body, and this center of mass will characterizes the whole body motion, right? Center of mass is a point at which the total mass of the system is supposed to be concentrated. It describes the translatory motion of a body, and it characterizes the whole body motion. It characterizes what? Whole body motion. So let us discuss about one by one what exactly the center of mass is. So have a look at it. So this is the ground, my dear students. So it's a ground here. So I have taken a disc. So this is the disc. Disc is moving like this. Disc is rolling, right? Disc is rolling on it. Same disc is rolling. Same disc is rolling. Okay. So there are the points I am considering, point A and point B. This is the disc, my dear students. It's disc. It's not a ring, disc. So this is what? A point C. So there is A. Sorry. After some time what happens? Imagine it is rolling, right? So it is rolling like this. It's rolling like this. So point G has come here and point B has come here. Point C is here. And after something, this is A and this is B and this is C. Again, it came back to the same concept, same position. So at A, I consider there is a mass. At B, I consider there is a mass. At C also, I consider there is a mass. And how this system of particles are moving due to the rolling motion of the disk, that's what we are going to focus. Let's focus on this one. At the point A, there is a mass, right? And how that mass is moving from first position to the last position. See here, how this mass is moving like this. This is how. How the point B, where one mass is located, that point B, how it is moving. See here. Can I say that point A is moving in a straight line? We cannot say. There is a zigzag path it follows. Only 3 positions we have taken. There are number of positions between these two for a disk. There are number of positions between these two for a disk. So zigzag motion each and every particle will take in this disk except one particle. Let's draw the motion of the particle which is at the center. I'm not talking about the center of mass. There is a particle whose mass is m is considered at the center. Okay, how that particle is moving from this position to this position to this. So if you carefully look at it, and this is what the particle C is moving. The particle C is moving. See here, the particle C is moving in a straight line, right? At each and every point, the particle C velocity will be same. So that's called the particle C is moving in a translatory motion, my dear students. And the complete body is moving in a straight line. The complete body is moving in a straight line motion. Understand? Clear? The whole system is moving in a straight line motion. Look at that definition once again. A point at which the total mass of the body of the system is supposed to be concentrated. Yes, and this is the point where total mass of the system is supposed to be concentrated. For example, this is the disc we have taken. So the disc is called a regular shaped body. This is called what? Symmetric and regular shaped body. So I am writing the same. So symmetric and regular shaped body, my dear students. Symmetric and regular shaped body. Carefully observe. For symmetric and regular shaped body, the center of mass lies at the center. The center of mass lies at the center. So for example, the same disc you take it, this is the disc whose center of mass lies here. So this is the disc. Okay. So let us take a rectangular plate. Rectangular plate, I said. Rectangular plate. So this is the rectangular plate will have the center of mass like this. So this is called a rectangular plate. And you can take a sphere also, my dear students. So it's a sphere. So which is solid sphere. Solid sphere will have its center of mass exactly at the center. Exactly at the center. So if you take a triangular laminar, it's a triangular plate, it's a triangular plate. So triangular plate whose center of mass lies at the centroid. Look at here, at the centroid, and that is called the meaning of symmetric. Symmetric bodies will have, regular shaped bodies will have the center of mass at the center. Now focus, my dear students. So there is a ring I am considering here. There is a ring. No mass inside the ring. Yes or no? No mass inside the ring. But still, center of mass lies here, my dear students. The ring. Center of mass lies here. Center of mass point may or may not have the mass. That's an important thing. Center of mass point may or may not have the mass. That is very important. Center of mass point may or may not have the mass. Center of mass point may or may not have the mass. Right? So, but because in the case of ring you see it. The center of mass lies at the center because according to symmetry, its center will be the coincidence of this one, intersection of these lines, right? Horizontal line and vertical line, if you draw, intersection of that line is the center of that ring. So at the center of ring, center of mass lies, but at that there is no mass. Right? There is no mass. Fine. Now, center of mass may lie within the body or may not lie within the body. For example, in case of sphere you take it, solid sphere you take it, within the body, inside the body, the center of mass is there. So, but in case of ring, not on the periphery of the ring. Here center of mass is not there, here center of mass is not there, here center of mass is not there, here center of mass is within the body, the center of mass point is not identified. But center of mass point will be within the boundaries of the body. For example, if it is the ring, right? Center of mass will not lie here. Center of mass will lie exactly at the center of the ring. Andre, within the boundaries of the ring. Understand? So this is about the concept of center of mass. And the second point what we discussed here, center of mass lies within the boundaries of the body. It may not lie on the body, outside the body it can stay, but within the boundaries only it stays. Coming back to the definition here. Describes the translatory motion of the body. Yes, exactly. This is the point which is moving with the same velocity, my dear students. This is the point which is moving with the same velocity, my dear students. So this is the center of mass, is describe the translatory motion of the body. And this is The body characterizes the whole body motion, whole system motion. The center of mass finally characterizes the whole body motion. The complete body is moving in a straight line, moving in a rectilinear motion, and that is what the final conclusion given by the center of mass concept. Okay, so for example, let's take this one, a cone, for example, cone. All right, cone. So this is the vertex of the cone, my dear students. So if it is a hollow cone, from the apex at a distance of, see, the complete distance h ankole, right? At a distance of 2 by 3 of h, center of mass point lies. Center of mass point lies. If it is a solid cone, for example, if it is a solid cone at a distance of 3 by 4 h, at a distance of 3 by 4 h, center of mass lies. Remember these two values, those two values are very important. Mostly the solid cone concept, it is important. At a distance of 3h by 4 from the apex, at a distance of 2h by 3 from the apex, in case of hollow cone, in case of solid cone, right? This h, height of the cone from here to here, right? And both these values from the apex only, remember, right? So this is how the center of mass concept introduction will be discussed. Now let's continue further, my dear students, and before continuing it, and listen, and this is the body which is hollow sphere. The center of mass point lies not on this place, not on this place. It lies exactly at the center, my dear students. Where mass is there or not? In the hollow sphere condition, center of mass point will have mass or not? Right. What's up? The question is, in case of hollow sphere, so at the center, mass is present or not? At the center of mass point, mass is present or not? Write it, right? So, in case of, this is a solid sphere, my dear students, solid sphere. So, it is a solid sphere. There is no air inside. It's a solid sphere. Completely, the body is made up of rubber. In this case, at the center, there is a mass. Center of mass point is having mass. Okay. And let's take another body here. This is called irregular shaped rigid body, my dear students. Sorry. This is called irregular shaped system of particles. Irregular shaped rigid body. Where the center of mass lies for this body, we don't know. Understand? We cannot tell. We need to calculate. So directly by using symmetry or regular shaped body like that, we cannot find the center of mass for that. We need to identify. How to find the center of mass point for the system of particles which are irregular bodies. So that will be discussed later. Okay. I just wanted to show it here. Now, center of mass of a two particle system. Let's have a look at it. So there is a mass 4 kg here. There is a mass 1 kg here. Remember, center of mass always lies which is close to the heavier mass. This is heavier mass. These are the 2 point masses. Point masses we are considering first. Point masses we are talking first. So center of mass of 2 particles, right? 2 particle system. So definitely the center of mass lies close to the 4 kg mass because it's huge, it's heavier. Imagine this is R1 and this is M1 and this is M2 and this is R2. Look at here, carefully look at here. What is R1, what is R2, you know, right? What is R1? What is R1? Center of mass point from M1. What is R2, my dear students? Center of mass point from M2. Carefully observe. The relation between that M and R we are going to get here. So mass is inversely proportional to that R, my dear students. What is that R? Distance of the mass from the center of mass. Distance of the mass from the center of mass. This is R and this is R. Distance of this mass from the center of mass. Distance of this mass from the center of mass. That's R, right? So look at here. So when this R increases, so the mass value must be less, right? For example, mass is less. Which is less here? 1 kg. R must be more, right? R. The distance between the center of mass and that particular mass will be more. Look at here. So, M1 by M2 is equal to R2 by R1. This is an important equation, the basics. This is just the basics, right? So, which I wanted to tell you, this relation, center of this relation finally concludes that center of mass point will be always close to the heavier mass. So, that is the 4 kg in this case. Alright, center of mass of the two particle system, let's have a look at it. So, there is a mass M1 and there is another mass M2. Let's suppose the center of mass point is here and there is a x-axis considered like this and the y-axis is considered like this, my dear students, and this is the origin. From the origin, x-axis first mass is located at a distance x1. That may be 2 meter, 3 meter, 4 meter, anything. Second mass is located at a distance x2. Have a look at it. It's no difficulty in it. From the origin can be taken anywhere. Origin you can take it at a M1. Origin you can take at the center of mass. This origin you can take at M2 also. No problem at all. Origin you can take this side also. No issues. This is the origin. From the origin, the first mass is located at a distance x1 and the second mass is located at a distance x2 and the center of mass is located at a distance xcm. Have a look at it. The center of mass is located at a distance xcm. All these values provided are from the origin, my dear students. x1, distance of the first mass from the origin, x2, distance of the second mass from the origin, xcm, distance of the center of mass from the origin, my dear students. Now, there is a formula you get here. Center of mass distance from the origin, how much? Xcm is how much? It is always m1 x1 plus m2 x2 plus so on divided by m1 plus m2 plus so on. It will be mn xn and it will be mn, my dear students. Look at here. Like this, if you keep n number of particles over there, here only we have two particles, so till here only your relation will be there. m1 x1 plus m2 x2 by m1 plus m2 as step. But I am writing a generalized expression where n number of masses you keep like this. From the origin, the distance of those masses are x1, x2, x3, x4, so on, xn by total masses here. Look at this. Right? And this is the basic expression where xcm you can write it as summation of I is equal to 1 to n mixi divided by, this is also the same, summation I is equal to 1 to n and this is mi. So this is what the general expression for identification of the center of mass of the two particle system. If this is along y-axis, the same thing goes here, my dear students. YCM is equal to m1y1 plus m2y2 plus so on divided by m1 plus m2 so on, right? So this is YCM along y-axis. Two particle system we are talking about. When the two particles are kept along y-axis, the center of mass we can find along y-axis from the origin like this. So what is YCM? What is YCM? What is XCM here? XCM is center of mass position from the origin along x-axis. What is YCM? Center of mass position from the origin along y-axis. This is the center of mass of the two particle system. And carefully coming back to this situation, my dear students. Carefully coming back to this situation. Observe here. So this is the equation. I can also write like this. Listen. So delta XCM. What is delta XCM? You know, change in the position of the center of mass. Look at here. If this mass position is changed, for example, case, let's see. This 4 kg mass position is changed like this side. So definitely center of mass position will change, right? Yes or no? Because the huge mass position is changing. Understand? So even if I change this mass position from here to somewhere here, center of mass position will automatically change, because center of mass position from the origin is depending on what? Positions of the x1 and x2. First mass and second mass positions are changing. Your center of mass position also changing, my dear students. So delta XCM, I can write it as m1 into delta x1 plus m2 into delta x2 divided by m1 plus m2. So this is how the numericals can be asked with this formula. With this formula also numericals will be asked, my dear students. Clear? Everybody? Sure? Let's have a numerical related to the system of particles or center of mass of the two particle system. Let's have a look at it. So this is the example. And a common example which you have already studied in gravitation chapter, which you will be studying in electrostatics, and again you are studying the similar question in this chapter also. What is this chapter? Have a look at it, and this is what happening here. Listen. So there is a origin. A mass m is placed at 1 meter. A mass 2m is placed from the origin at a distance 2 meter. A mass 3m is placed from the origin at a distance 3m. Right? A mass 4m is placed at a distance 4 meters. So like that, n number of masses. N number of masses. Now the question is, what is XCM? Simple question. What is XCM? Right? So the formula for the XCM is what? m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3 so on. So what is XCM? Let's identify. What is XCM here? m1 is m into x1. x1 is the distance from the origin to the first mass. It's 1 meter, plus m2 is 2m and x2 is 2 meter and m3 is 3m, x3 is 3 meter, plus so on, divided by m plus 2m plus 3m, like that. So XCM is equal to, here m if you take common, 1 square plus 2 square plus 3 square plus 4 square plus so on. You know this sum, right? You know that sum, arithmetic operations, arithmetic progression, right? So now this is m into, it's 1 plus 2 plus 3 plus so on. M cancel, my dear students. And if you continue here, what happens? XCM value. So the numerator will be n into n plus 1 into 2n plus 1 by 6 divided by, what is this? This is n into n plus 1 by 2. Understand? So this is n into n plus 1, n into n plus 1 cancel. 2 1s are 2 3s, right? So the final answer is what, my dear students? XCM is equal to, here I am writing this one. Final answer is what? Is it a 2n plus 1 divided by 3, my dear students? Is it 2n plus 1 divided by 3? 2n plus 1 divided by 3? So like these questions also will be asked, right? And let's see one more numericals related to position, change in position of the center of mass, my dear students, right? Alright, my dear students, and center of mass of two particle system we have discussed, and those two particles we have kept in the horizontal direction, or we have studied the formula when we keep those two particles in the vertical direction, right? Now The point is that center of mass of system of particles in a two-dimensional plane, my dear students. In a two-dimensional plane. So what I have told you already about a rigid body. For example, this is the rigid body I have, which is having n number of particles with it. So let's take a particle of mass m1, which is having the coordinates x1 comma y1 in the plane. So if you consider there is an x-axis here and a y-axis, xy plane here. In the xy plane, this rigid body is kept. At one particular point, mass of the particle is m1 considered, which is at the coordinates x1, y1. There is a second mass somewhere here it is considered, second mass m2, whose coordinates are x2, y2, like this so on. m3, m4, m5, so many. So there is center of mass point is also considered, whose coordinates are xcm, ycm, my dear students. This is the center of mass position. Look at here. Along x-axis, it is at xcm. How we find this xcm? You know the formula. m1 into x1 plus m2 into x2 plus m3 into x3 divided by m1 plus m2 plus m3. Okay. So along y-axis, the center of mass position is ycm from the origin. This is the origin. This is how we find the center of mass of the system of particles in two-dimensional plane. Right? So here xcm, how you will find out m1 x1 plus m2 x2 plus m3 x3 plus so on divided by m1 plus m2 plus m3 plus so on. It goes like that. And ycm, if you want to find out, so that will be m1 y1 plus m2 y2 plus m3 y3 plus so on divided by m1 plus m2 plus m3 so on. For example, if somebody asks you to find the distance d from the origin to the center of mass, what is the distance? So this distance you can find by using Pythagoras theorem, my dear students. So this is d and this is ycm and this is xcm, simple, right? So this is d and this is ycm and this is xcm. So this is ycm line. So by using Pythagoras theorem you can find. So distance of the center of mass from the origin. What is that? So d is equal to square root xcm square plus ycm square. So little advanced level hodre ee tara questions also can be asked. Right? Little advanced level. And let's see the numerical based on this. Let's see the numerical based on this and commonly asked question in the NEET and JEE exams. So commonly asked question. So what is this? So there are 4 particles are connected in a square. Imagine it's a square. So this is the mass 1 kg is kept at 1 point and 2 kg is kept here, this point, and 3 kg is kept at this corner and the 4 kg is kept at this corner. So this is 1 meter, 1 meter, 1 meter, 1 meter, right? A square is kept like this. So the question is find the center of mass of the system. Have a look at it. The question is find a center of mass of the system, my dear students. Find the center of mass of the system. And how simple it is? Look at here. How simple it is? Look at here. Find the center of mass of the system. So to find the center of mass of the system, always we have found the center of mass from the origin only, right? From the origin only, the center of mass position always we are finding from the origin. Okay. Here also the same, from the origin we are finding. Where is the origin? That is important. Alright. So find out your x and y axis immediately. So this is what my x-axis I am imagining. This is x-axis, and this is what my y-axis I am imagining, and this is the origin. The first mass is considered as origin, my dear students. First mass we have considered as the origin. Now, first mass coordinates we'll write it, because center of mass somewhere lies here, somewhere it lies here. So its coordinates will be xcm plus into xcm comma ycm. So this is the center of mass. So center of mass position of the system, if you want, you need xcm and ycm. xcm formulas are here. m1 x1 plus m2 x2 plus m3 x3 so on. ycm formula also here. So to find the center of mass of the system, we need to find xcm and ycm first. How to find xcm? To find xcm, we need x1, x2, x3 values. To find ycm, we need y1, y2, y3 values, my dear students. How to find them? Look at here, look at here. Very important, very important. So let's write the coordinates for each and every mass. For the first mass, coordinates are what? So 0, 0. Will you agree with that? For the first mass coordinates, x1, y1, it's a 0, 0. For the second mass coordinates were what? Second mass is kept at 1 meter along x-axis, and along y-axis it's 0. So this is called x2, y2, second mass coordinates. Third mass coordinates also we can write. Third mass is kept along x-axis 1 meter, along y-axis also 1 meter. It's a 1, 1. It is x3, y3, my dear students. How easily we are discussing, let's see. Fourth mass coordinates you can write x4, y4. What is that? So fourth mass along x-axis, fourth mass is at 0 position. See, along x-axis it's 0 position. So this is 0. Along y-axis it is 1 meter. Look at here. So this is x4, y4, my dear students. That's it. You know mass values, you know x1, y1, x2, y2, x3, y3, x4, y4. That's it. So let's find xcm. What is xcm, my dear students? m1 x1. Look at here. m1 x1. What is m1? First 1 kg into x1. x1 is 0 plus m2. What is m2? 2 kg into x2. What is x2 here? 1 plus m3. 3 kg into x3, it is 1 plus m4, 4 kg into x4, x4 is 1 meter, that's it, divided by, right, x4 is 0, see here, x4 is 0, divided by m1 plus m2 plus m3 plus m4, and what is this, my dear students? 0, 0, okay, 2, 3, 5 divided by, what is this? 3 plus 3, 6, 6 plus 4, 10. Yes, wonderful. So 0.5 meters we have got. 0.5 meters. From the origin at 0.5 meters, 0.5 meters, xcm is located. And where the ycm is located here? m1, y1, 0. m2, y2, 0. m3, y3, look at here, y3 is 1. Alright. m4, y4, y4 is 1. Divided by 1 plus 2 plus 3 plus 4, which is equal to 0 plus 0. And this is 3, 4. It's a 7 by 10, my dear students. It's 0.7 meters we have got. 0.7 meters we have got. So xcm and ycm coordinates, you see 0.5 comma 0.7. So somewhere they lie here. Somewhere they lie here. Alright, see here. This is the xcm position. Along x how much? 0.5 meter. Along y how much? 0.7 meters. So that is xcm ycm points. So 0.5 meter, 0.7 meter. At these coordinates, so this center of mass lies. Alright. Now you should practice this. This is the homework for you. You should practice this and send me the solution in WhatsApp, right? There is a triangle, equilateral triangle. Each side is 1 meter. 1 kg mass is kept at this, and another kg is kept at this corner, and another one 2 kg. Let's see. It's 2 and it is 3. It's kept like this at different places, at corners. Now the question is, find the center of mass of the system, my dear students. Find the center of mass of the system. How to find the center of mass of the system? The first thing, you need to keep your x and y axes. So this is, you can take your x axis, hint I am giving. So this one, you can take your y axis, hint I have given. So this is m1, x1, y1 coordinates you find out. This is m2, x2, y2 coordinates you find out. This is your m3, x3, y3 coordinates you find it. Use these formulas xcm, ycm, and you get the answer, my dear students, right? Like this, the numericals will be asked, right? What I have told you, shift in the center of mass. We have already discussed about the basic formula. Xcm is m1 x1 plus m2 x2, for example, 2 particle system, okay, by m1 plus m2. And we have also discussed delta xcm is equal to m1 delta x1, m2 delta x2 divided by m1 plus m2. So what is the delta here? Change in the position of the center of mass. Look at here. Change in the position of center of mass along x-axis only. And what is delta x2? Change in position of the second mass. So what is delta x1? Change in position of the first mass. Okay? And let's see this numerically. So this is the ground on the x-axis. There is a mass 10 kg here. There is a mass 30 kg here. There is a center of mass position will be there, which is close to the 30 kg. That is center of mass position. See, this 10 kg mass is moved right by 12 centimeters. Listen. 10 kg mass is moved rightwards by 2 centimeters. To keep the center of mass position is fixed. By what distance this 30 kg mass must move? That's a question. Here, this is m1 and this is called a delta x1 is 2 centimeter, my dear students. This is m2 and that delta x2 is how much? If you move one mass, center of mass position definitely will change, obviously will change. Without changing the center of mass position, by what distance this 30 kg mass need to be moved? That's a question. Alright, that is the question. Simple, let's start. So this is the formula we use. Delta xcm. What is delta xcm in this case, my dear students? What's up me? What is delta xcm? So today you need to practice this. This is your assignment today. You need to practice each and every point we discuss now. Get ready for the exam. There is no assignment is given. Get ready for the exam. Okay, have a look at it. So what is that? What's up mean? What is the change in the center of mass position in this diagram, in this question? What's up mean? Is it 0? Yes, the question told this is the mass is shifted by 2 centimeters right side. To keep the center of mass position is constant, at what distance the 30 kg mass need to be moved? That's the question. Okay, delta xcm is 0, which is equal to m1. m1 is 10 kg into delta x1. It's 2 centimeters, my dear students. 2 centimeters, right? Plus, so this is the right side. I am taking it as positive. Okay, now m2, it's a 30 kg into delta x2, that is what I need to find, divided by m1 plus m2, it's a 10 plus 30, right? This 10 plus 30 is 40, 40 into 0 will be 0. So 0 is equal to 20 plus 30 delta x2, okay? So your 20 is equal to minus 30 into delta x2, 0, 0 cancel here. So what is this? Delta x2 is minus 2 by 3 centimeters. What is minus here? What is minus here? So minus means this 30 kg must move left side. When you are moving this 10 kg right side, this 30 kg must move left side in order to keep the center of mass is unchanged. By what distance? By 2 by 3 centimeters. By what distance? 2 by 3 centimeters. Minus indicates left side. That is the answer. So, when you disturb this 2 centimeters right side, you must disturb this 2 by 3 centimeters left side so that the center of mass position will be same. Right? This is a little advanced level question, my dear students. Right? And the questions can also be asked like this. So this is 0 anta kottidrega. It is not changing anta. Sometimes this will change and this will change. They will give the values, right side, left side, you need to apply the sign convention, and finally they will ask you to find delta x. Delta x here. Alright? So that's it. All the very best for your exam, and you must practice. These are the things which are not connected to any of your previous 9th and 10th standard things. That's the reason we are discussing this chapter at the last. Right? So that is why you need more practice on it, that's there, right? More practice on it, and anyhow, our support will be there always with you. Bye bye and shining off. Take care.